everybody. Welcome to the BCS SM-ITAM webinar with Tim Payne. He's going to be talking about cloud stuff. I'm Kylie. So just before we start, I just wanted to mention that we've got a couple of actually throughout March, we've got a load of joint events that we're running with the BCS project management group, and they're actually service management people who have been involved in or who have run a service management project, and they're doing presentations all through March. So if you want to find out more, we've got one talking about 20,000 project management, service management, and ISO IEC 20,000-1 is on the 9th of March. On the 16th of March, we've got planning the successful design and delivery of a service. On the 23rd of March, we have service management and project management, a synchronized dance. And then on the 30th of March, we'll be rounding off the spring school, as we're calling it, with a service management and project management panel session. And our own Richard Josie, who's the chair of our group, will be attending that. So if you're interested in finding out more, I'll just put the link in the chat. So there we are. Now, the other thing I wanted to mention before I hand over to Tim is that we have a YouTube channel. And on that are the recordings of all the webinars that we've been running over the last few weeks. In fact, over the last couple of years, I should really say. So if you missed out on anything, or you want to go and have a bit of a browse and see if there's anything of interest, any webinars of interest, then please do pop in there and take a look. And again, what I will do is I will just put that in the chat as well. I just need to get the link. Right. Sorry, I'm just faffing around on YouTube. So we've actually got a playlist that you can take a look at as well. Right, so here's the link to the Service Management IT Asset Management playlist on YouTube. So I think that's about it, really. Tim will be doing his presentation, and he'll pause a couple of times in the presentation for questions and comments. So if you can put any questions or comments that you have as he's talking into the chat box, then when he pauses, I'll read out the questions and discuss them with Tim. So we find that actually works quite well. We can often have quite engaging conversations that are really quite interesting. So I think that's it from me. Please do take a look at our YouTube playlist, and also take a look at the events that we're running as joint events with Project Management Group next month. And I'll hand over to Tim. So I hope you all enjoy, and please do put your questions and comments in the chat box.
Okay, so thanks, Kylie. I'm here. Right, so if you've not heard of me before, my name's Tim Payne. I did do one of these sessions before during the conference, I think it was late last year, where I was talking about other bits of cloud stuff, as Kylie put. But basically what I am is like a cloud architect, cloud engineer. I'll talk a bit more about myself in a bit, but today we're going to be talking about cloud migration. Is it really that scary? And lots of other cloud stuffy as well. So without any further ado, let's get started. So the agenda for today's meeting, I'll talk through basically who I am and what I do. I'll talk a bit about cloud and cloud native services and what they are. I'll talk a bit about cloud migration strategies and approaches. We'll cover a few use cases from a technical perspective. We'll look at some business impacts of doing a cloud migration. And then I'll finally finish off with a summary of what we actually discussed. And I'll give you some final advice as well. As Kylie said, I will stop at a couple of places for taking any questions. Actually, probably be given the amount of content I've got to go through and the time, I may just leave it with one halfway through and one towards the end. But if we get some more time, I'll stop at some other places as well. So without further ado, let's get started. I'll just give you a quick warning before I start. What I'm going to be talking about is very generic. Now, migrating to cloud can be very context specific based on the types of services and the use cases that you're migrating. So your mileage from this presentation may vary, but I'm going to cover probably the fundamental concepts, and the advice in here will be applicable to most migrations you do, but you may need to tweak the approaches that you take depending upon the specifics of your migration and what assets you're actually migrating to the cloud. So just be aware of that. Okay, so that's enough of the boring stuff. Let's get started into the interesting stuff. So my name is Tim Payne. I work for a company called And I'm one of their DevOps lead and principal. I've been in the IT space for about 25 years now. God, has that been that long? Most of it I've been in the IT sort of development side, so mostly software development in the SCM, CM, and process management space. For the last 10 years, I've been focusing mostly on the sort of architecture, DevOps, and cloud space, doing things like cloud architecting, helping with pre-sales, putting together cloud migration projects, helping enterprises go through the torture that they need to do to implement DevOps and cloud in their systems. So I have quite a few bits of experience with this area. If you want to sort of link with me, you're more than welcome to. I believe a copy of this presentation will be available at the end of the session. So if you want to get in with me on LinkedIn, then there's a sort of link up here, which will take you through, and we can connect. Okay, so that's enough about me. Let's get into the more interesting stuff. So what I'm going to do is I'm going to start off by talking a bit about what is cloud and cloud native services, and then I'm going to cover basics of what cloud migration is before we start jumping into the more specifics of the technologies involved. Okie dokie. So let's start by looking at what is cloud and cloud native services. So the best way of thinking about cloud is a definition like this. Simply put, the cloud is a set of pay-as-you-go infrastructure and other services hosted by a cloud provider that can be rented on an as-needed basis. So basically, it's something that a provider provides that people like us can then go and rent what we actually need from that provider. There are three main types of cloud. There's the public cloud, which is where there are cloud services that are available for anyone to rent. So, for example, AWS, Google Cloud Platform, or Azure. Those are all very good examples of public clouds. There's hybrid clouds, which are when environments include both on-premise and cloud hosted services and infrastructure working together, which is probably one of the more common implementations that people do at the start. And the final one is private clouds, which are when there are cloud services built, owned, and used exclusively by a single organization. The ones I'm actually going to be focusing on today are the public and hybrid clouds. You'll may come across organizations that use private clouds, but basically what we are going to be talking about as far as the migration processes will probably be different for those private clouds. So that's why I'm not actually going to be focusing on them during this presentation. Okie dokie. So I've talked a bit about a cloud provider. Now, what is actually a cloud provider? Well, at its simplest level, a cloud provider is someone who is there to host the infrastructure and services that are rented by an organization, i.e. they provide the infrastructure and services that are rented and used by people like us. They are responsible for investing and maintaining those services. So they are responsible for all of the capital expenditure and capital investment to set those services up and maintain them. And they're also responsible for charging people like us based on the services that we use, which is what we commonly call OPEX, or operational expenditure. So the big question is, why do you actually use cloud? Well, the main reason is cost. In the long term, it is often cheaper for organizations to rent what they need, i.e. that OPEX, as we call it, rather than build it out themselves, i.e. undertaking that capital expenditure. So when you look at trying to start building a business case as to why you want to move to the cloud, then a very good place to start off is in this capital expenditure, or this CapEx versus OPEX cost argument. That's usually a very good place to start when you're looking at business cases. So we've talked a bit about cloud, and we've talked a bit about cloud provider. But now, what are cloud native services? Well, the easiest way to think about cloud native services are that it's a term that refers to services and infrastructure that are hosted by cloud providers. And the way I tend to think about them is that I split them into three main types. The first one is what I call the compute services, or the do services. And these are things like VMs, compute instances, application servers, applications themselves, anything which basically does something or processes something. That's what I tend to term as a compute service. Then we have the network service, and this is the things that actually connect different types of resources together. So if you're familiar with the terms VPNs and load balancers and routers and subnets, those are all part of the network services. And then lastly, the main type of cloud service we have is what we call the data services. And these are things that manage and host data. So things like databases, NAS storage, disk storage, file servers, anything like that, which actually hosts data, that is a part of a storage service. Now, of course, those aren't the only ones that are available. I mean, there are things like AI services as well, but those are pretty custom, and you only really look at migrating those in specific use cases. So the ones that we're going to talk about mainly today are going to be focusing on compute, network, and storage. Okay, so I've talked a bit about what cloud is and the types of services that are in the cloud, but now let's have a look at what is cloud migration and some general cloud migration approaches and strategies. So first of all, what is a definition of cloud migration? Well, at its simplest, cloud migration is all about moving all or parts of your data, infrastructure, or compute services from your on-premise system into a specified cloud provider. And that's basically what it's all about. So there are 6 main types of migration strategy that you can use, which we call the 6 R's. The first one is the simplest one, which is generally known as rehost or lift and shift. And basically what you do here is you have a compute server or an actual physical server on your on-premise system. You virtualize that into a VMware image or a Hyper-V image. You upload that image to the cloud, and then you basically just run your compute from that image. So it's effectively a lift and shift approach. Then we have what we call a replatform. And this is where you basically move on-premise services as is to the cloud using cloud native alternatives. So for example, a good example that most people tend to start off with is you may have a database, like maybe a Postgres database, which you're running on your on-premise system, and you want to move that to the cloud. What you can do is you can simply create a cloud native hosted database, a Postgres database, and just then simply move the data from your on-premise Postgres database into that cloud managed Postgres database. And that's what we call replatforming. And that's mostly about moving into what we call PaaS services, which are platform as a service services. Then there's something called repurchase. Now, this is a bit more of a specific use case. This is where you move your services where they are available to a SaaS offering. And the most common ones are things like Office 360 Office 365, get the right name, G Suite, and you use that for things like email, documents, etc. But there are other types of sort of services you can move to SaaS offerings as well. But mostly it's for things like email and documents. Then there's what we call refactoring. Now, refactoring, this is where you partially or fully redesign your service architecture to make best use of cloud native services, i.e. what we call microservices. Now, I'll talk about those in more detail later, so just park that in your mind for the moment. Then there's retain. Now, retain is basically where you say, okay, the cost of actually moving the service from our on-premise system into the cloud is so much, it's going to involve so much effort, it's going to cost so much that it's just simply not worth it. We might as well just leave them where they are. And the usual use cases that you have with that are when you have something like a legacy system or a system which has a a highly customized set of backends or is really intertwined into your sort of on-premise system. So the actual amount of effort and cost untangling it and sort of migrating it over to the cloud just simply makes it not worth it. You might as well just leave it where it is. So that's what we call retain. And then the final one is what we call retire. And this is basically where you decide that, the service that we have here, there's so few people using it, or it's so old that we might as well just retire it and replace it with something that's in the cloud anyway. And that's what we call the retire. It's basically where you replace an existing service and then you discontinue the service on the on-premise system. So that's basically what we call the 6 R's, which are the fundamentals of how you would actually do a migration. So next, let's have a look at a sample project topology or a project methodology that you might use when you're actually looking to run a migration project. Now, this is a common approach that I've used with quite a large number of customers. Most of those customers have been sort of middle-sized to enterprise scale sort of enterprise, and it actually works quite well with them. And it's basically based around a 4-stage or a 4-phase approach. So you have a discovery phase, followed by an assessment phase, followed by a migration phase, followed by a stabilization of your run state phase. And basically what you're trying to do is in each phase sort of build up the different bits and pieces that you're actually going to migrate and the sort of scope of what it is you're migrating. So in the discovery phase, what you're doing is you're basically starting off by scoping what it is you're going to migrate. So you're looking at the assets that you have. You're actually saying this is what we're actually trying to do for the migration. So this is the scope of the assets that we're going to migrate. So then once you've done that sort of scoping activity, then what you do is you create the business case. So for example, you look at the timescales involved, you look at the types of allocation of budget that you might have to make the migration happen. You look at any sort of maybe there's some legal requirements that you need to take on board, things like GDPR or SOX requirements or ISO requirements. So you sort of note those down in the business due diligence that you do, just to make sure that you've actually tracked the business case and all the impacts that that business case will have. Then you do your technical due diligence, and that's where you basically start to discover the assets that you need to migrate over. So you start to interrogate your CMDBs, you start to look around your infrastructure, your topology, your networks, and you actually sort of say, well, these are the types of assets that we need to move over. This is the topology of those assets. So those are the ones that we do the sort of discovery and the technical due diligence on. So the discovery is best thought as being the process that you use to define the business case, set the scope, and then sort of discover the assets you're actually looking to migrate. And then we have, after we've done the discovery phase, then we have the assessment phase. And in the assessment phase, what you're looking to do is basically assess the business impacts that your migration will have. So, what structures, what processes are we going to have to change? Are we going to have to get some legal advice about how we're going to make these systems compliant to GDPR? Or any of the ISO sort of standards that we need to do. You also look at the technical assessment. So you basically go through the assets that you want to migrate into your cloud provider, and you basically say, okay, what's the target topology that we want to migrate into? Are we going to run any POCs to actually test the migration process? Because believe me, you will want to test the migration process. You also might actually create a backlog. So you'll in that backlog, you'll list the types of assets that you want to migrate. You'll list the types of activities to do those migrations. And you might also, if you're using like an agile approach, maybe you'll define something like an MVP, which is a minimal viable product for your actual migration. Then you'll look at doing your migration planning, and then finally you'll get everyone to sit down and review it to make sure they're happy with that approach, and then get approval for it. So the assessment is used to plan the migration and see potential methods of doing it. Then we actually do the migration process itself. So once we've got the assessment done, then we leap into doing the actual migration. So we do the technical migration, which is sort of migrating the assets over to the cloud. We do the organizational migration, which is basically changing the processes that we need to, or adapting our structures as we need to. We then stabilize what we've actually migrated into the cloud. So we make sure it's actually running as we expect it to run, that, you know, the security is actually set up, that it's performing within our NFRs, that we've got the monitoring set up, and that we've got the budgeting sort of cost control set up, things like that. And then we finally prep our handover to the SRE or ops functions to make sure that they are ready to take on board what it is we're going to actually hand over to them. So the migration phase is therefore about running the planned migration and making sure that the run state is available to actually take what we give it and actually run with it. So the run state is the final thing. That's basically where the teams that have been going to take on board those cloud assets are actually going to be able to use them, maintain them, do incident management on them, and just basically make sure they work going forward. So that's a typical cloud migration project methodology that I've used in the approach, that I've used in the past, sorry. And as I say, that actually tends to work quite well as a way of starting out at looking at how do I put together a possible migration project. Okay, so we've talked a bit about migrations. You know, we've talked a bit about how you might do a migration, but what services and features might you actually typically get migrated? You know, so we've got this big infrastructure. Here's a list of what I've done in the past as a more common perspective. So first we look at, you know, what sort of data do we need to migrate? So that might involve static data, it might involve SQL databases or NoSQL databases, and it might involve, you know, sort of file stores, things like NAS servers. Then I look at sort of things like the network topology. So we've got our on-premise network, which is full of, you know, VNets, subnets, load balancers, firewalls, VPNs, etc. We need to assess how we're going to migrate those to the cloud. Then, of course, will be the compute services. So our applications and our actual physical servers. We need to assess how we're going to migrate those to the cloud. Then, if we're actually developing software, maybe we also need to look at, do we need to migrate our DevOps processes to the cloud, or do we actually need to set up new DevOps processes in the cloud? Because one of the reasons we're going to the cloud is because we want to make use of DevOps processes. So that would be yet another thing we need to consider. Then if we're using projects and business structures like business units to actually isolate the sort of people or scope the people who have access to sort of different types of infrastructure, then we need to think about how we're going to model those projects and business units or general organization structures in the cloud as well. Now, there are ways of doing that, so that's something you can also migrate over to the cloud as well. Then we need to consider our security. So when we have all of our security setups on our on-premise system, we need to think about how we're going to migrate of that on-premise security and reflect it into the cloud. So are we going to set up web application firewalls? Are we going to set up things called security groups? How are we going to isolate different types of resources if we want to basically isolate them so no one else can access them? How are we going to manage secrets? How are we going to manage keys? How are we going to actually monitor our security system so that if breaches do happen, that we can actually do something about it? So that's also an important part of migrating to the cloud. Then we need to think about our budget. You know, how are we going to sort of monitor and control the resources that we set up and people run in the cloud? That can be quite a something that is very important that people often forget. I came across one use case, I think it was about 2 years ago, where someone had done a migration to the cloud and hadn't really set up the budgeting controls. Some developers actually set up some resources, you know, quite well-meaning, They left those resources running over the weekend, and lo and behold, when they came in on Monday, they found that they had burnt through, I think it was $15,000 of budget, unintentionally, just simply by having resources running over the weekend that no one was using. So being able to control the resources and make sure that you're actually monitoring the budgets is also an important thing that you need to consider when you're going to the cloud. Other areas would be observability. I hate that word, and SRE, which, if you never heard that term before, it stands for Site Reliability Engineering. So that involves things like, how are you going to monitor the systems that are running? How are you going to make sure that they do run and that they're stable? How are you going to do things like incident management? How are you going to manage alerting? How are you going to manage patching, availability? How are you going to basically keep the system running? That's something that you need to look at when you're actually looking at the cloud as well. So some of the policies that you might have from your on-premise ops teams, you might be able to transfer those to the clouds, but a lot of the technology you'll naturally need to set up anew within the cloud as well. Then, of course, we have IAM policies. So you've got users, roles, groups, privileges, Active Directories or LDAP directories. How are you going to set those up? Are you going to migrate those to the cloud, or are you going to stay, or are you going to keep them on premise? So that's something else you might need to consider when you move into the cloud. And the final one, control and management. So, how are you going to maintain overall control and oversight of the cloud resources that you're setting up, the cloud processes that you're setting up, and how are you going to make sure that they are operating within normal parameters? So that's something else you might need to consider. So as you can see, there's rather a lot of stuff there you might need to think about when you're actually moving your services to the cloud. Unfortunately, due to time, we're only going to consider a couple of them, but I will give you some advice on basically how you might do these and how you might set these up in the next sections. Right, so we've gone through quite a few sections and we've covered quite a few bits of material. So let's take a quick breather. And Kylie or Conrad, are there any questions that have come through that people want to ask?
So we do have one question. So Vittorio asks, is there a general ROI rule when migrating to the cloud? For example, size of organization, amount and type of data, global distribution of users and data. Any thoughts on that, Tim?
Yes, it really depends on the specific use cases. There is usually a reason why you start to look at why, as an organization, want to move to the cloud. And it's usually to do with things like scalability of resources. It's usually due to things like being able to keep the costs under control. I've got a section on it in the following slides, so maybe we should push it back to then, and if there's any other thoughts, we can take it at the end. But basically, it really comes down to the use case or the business case that you're actually doing for cloud migration. I've found that a lot of times there's different reasons why people want to move to the cloud. Sometimes it's cost, that's the biggest one. Sometimes it's security, and sometimes it might be because they actually want to have a system that's going to be able to scale at the sort of throughputs that they actually need. And the only way that they can do that is move to the cloud. So it really depends on the actual use case that you're trying to create when you're actually moving to the cloud. But cost would generally be a good place to start, either cost, security, or scalability. But we're going to cover that more in the section after section 3.
Fantastic. So please do put your questions in the chat, everybody. So the only other question we have at the moment is, will the recording be shared? And yes, for those of you who haven't seen that, the answer in the chat, yes, we will add it to our YouTube channel. It usually takes a couple of weeks to be edited and topped and tailed with the BCS branding. So we'll let you know when it has been added to our YouTube channel. Any other questions quickly? Type away, people.
I can add something. Are we going to share can we make the presentation itself available, Kylie?
Yes, so that will be available on the event
cool.
page. Yeah.
Because as I said, when I put these presentations together, I try and put as much overload of information in them, which might not be great for some people, but I find that you only take about 10% of the information that's actually talked about during these sessions. So it's always a good way to sort of go back and then have the presentation full of the information, and you can read that sort of afterwards.
Yeah.
Some people may like it, some people may not, but I do. Okay. So I'm assuming that's going to be it for the questions for now.
For the questions at the moment. Yeah.
Okay, I will jump into the more interesting stuff then. Okay, so we've talked a bit about what cloud is. We've talked a bit about what cloud native services are. We've talked a bit about cloud migration approaches, and we've talked a bit about sort of how you might actually scope the services that you want to migrate into the cloud. Now we're going to actually talk about the technical stuff, which is how you might actually do some of these migrations. Now, again, what I will be covering is fairly generic and at a fairly high level, but it should give you enough information to give you a start on how to actually look at how you can migrate services over. And as I say, at the end, we can, if we've got time, dig into more technical cases on how you might be able to approach it. Okay, so jumping into use cases. So we're going to be looking at migrating how we would migrate over 3 different types of use cases or services here. We're going to be looking at how we would do data migration. We're going to be looking at how we would migrate over the network infrastructure. And then finally, we're going to be looking at how we'd migrate over the compute resources and applications. I.e., if you remember, that's any sort of service that is doing something or processing something. It's not just compute infrastructure. It might actually be applications as well. So let's start off with data migration, since that's the easiest. Now, there are 3 main different types of data that you can actually migrate over to the cloud. And for 2 of them, the approach is usually exactly the same. So the first type of data is what we call static data. And this is usually what we refer to as blob data, or binary long objects, if you're familiar with the term, or CSS data that you use in websites. So it's basically data that you create once and then you read many, many times. So a good example might be videos, training videos, process documentation, templates, anything which is basically sitting somewhere on a repository that you want to move to the cloud, because maybe you want to be able to put it into things like cloud edge of presence systems. I can't remember what they call them now. Content distribution networks, that's it, to make access from different regions easier. So for doing these, there are 2 main methods of sort of migrating that data over. And it really depends on the size of the data. So the first one would be migrating it using online transfers. So that's simple things like upload or rsync methods, if you're familiar with the term rsync. So if your data is small enough, a couple of terabytes or a couple of 100 terabytes, then you can, as long as your network connection is up to it, actually migrate that data using online methods, or upload online methods. The second one is the offline methods, and this is where you're using things like transfer appliances or archival media. And you would typically use that method if you're dealing with data which is petabytes in size. And what you'd usually do is you basically contact the cloud provider or one of their representatives. They would send you what's called a transfer appliance or a set of transfer appliances or archival media. You would then offload copies of all of your data onto those transfer appliances or that archival media. You would then ship them manually back to the cloud provider, and they would basically upload it from that transfer media into their systems directly. And that's probably the only way of dealing with data which is petabytes in size, which is more common than you think. The next type of data is what we call file data. And this is things like file and directory data. So, the contents of maybe NAS servers or NFS disks, anything which has file or directory data. And again, the method you transfer them is virtually exactly the same as the static data. You use online or offline methods, again, mostly depending upon the size. The interesting one, or the more complicated one, is the no or SQL data, i.e. the database data. Now, the method you use here will really depend on the sort of data the database you're taking your data source and the database you're actually targeting your database upload to. If they are the same type, then you could do things like export import. That works very well with some databases. If you're using the same type of database, and that database management system supports standby databases, then you can do what's called instance syncing, which is where you create a database in the cloud. You set that database up as being a standby database, and then you basically allow the database manager to actually sync all the data from your main database into the standby database, which is in the cloud. And then once that syncing's finished and you decide to switch over, then you basically make your standby database the master database, and everything's fully in sync. Other methods would include ETL methods, which are really useful when you're going from sort of different types of databases to different types of databases. Some of the databases do actually have migration utilities. So for example, in Azure, there's something called a database migration piece, which works very well with MySQL. And if you really want to get primitive, then you can use, literally just move the database files over, just treat your database file as being a set of file data and just upload it, or transfer it using offline methods. Or if you really want to be very primitive, then you could just basically virtualize your database server, and then just basically transfer the server as a lift and shift method. So you virtualize it, turn it into a VMware image, upload that to the database, up to the server, up to the cloud, sorry, and then run the database as a VMware image. So there are quite a few ways of being able to do database migration, depending upon what database you're going from and to, and the different types of sort of control that you want over that database. So that's the easy one. The next one is what we call the network or the topology migration. Now, network migration is usually quite manually intensive. And this is because it involves actually mapping the physical infrastructure and topology that you have on your on-premise system into your cloud provider specific IaaS. When I talk about IaaS, what I'm talking about is infrastructure as a service. Now, if you're not familiar with infrastructure as a service, then I please ask you to look it up, because we could carry on trying to describe these terms forever and go into the details of them. And it's probably best if you do that research offline. Now, the problem is that each cloud provider has its own specific IaaS setup. So, for example, in GCP, they have something called virtual private clouds, which are global. In AWS, they have virtual private clouds, which are regional specific. And in Azure, they have they don't have virtual private clouds. What they have is called virtual networks. So you actually need to go through a manual process of actually mapping your network infrastructure to the actual specific IaaS that the cloud provider has, which can be a bit of a pain, to be honest. But here's one approach that I would suggest that you use to actually look to do it. And it actually works quite well. So we start off by reviewing the existing topology and the relevant architecture that we actually want to transfer into the cloud. We would then manually map that topology to the cloud provider IaaS services that are relevant to what we're trying to transfer into the cloud. We would then define what we call define what we call environment profiles. So if we have like a development environment, or if we have a test environment, or if we have a production environment, then we would define a profile for each of those environments, and we would list properties like, what web servers are in there, what database servers are in there, what regions do they sit in, what are the cipher ranges of those networks and subnetworks, what load balancers do they make use of, what are the memory configurations of the various servers, information like that. So we basically want to profile all of the resources that are in each of those environments. Then what we do is we actually codify those profiles. So if you're familiar with, I probably talked a bit about this before in the previous presentation that I did during the BCS conference, if you were there for that. What you do is you use what we call this IAC, or infrastructure as code. And what you do is you codify each of your profiles into this infrastructure as code. So for example, you can do it using coding languages such as Terraform, if you've ever heard of that, a very common approach these days to use. Or if you're specifically into sort of CM, configuration management, then you can use tools like Ansible. Or if you're going to a specific provider and you want to use that specific provider's language, then you might want to use something like maybe ARM templates for Azure, or code formation for AWS. But my advice would be to use Terraform, simply because it's the most common one, as you can say. It supports most of the providers, and there are some commonalities in the language constructs that you can actually use. So once you've coded and tested those profiles, what you then do is, because it's code, you basically modularize it. So you're not just going to be, or it's very uncommon to have sort of like a web server that's unique for each profile. So what you try and do is you try and refactor your definitions so that you can sort of pass in parameters and then reuse those modules of IAC for each of the different environments. So that means that you can sort of cut down the amount of testing that you do, cut down the amount of code that you have. So once you've modularized your IAC, you can then deploy it to the cloud. And what my advice would be as well is that you actually, if you're going to be doing multiple deployments, which is if you're actually building up things like test environments, you're going to maybe strip down test environments and replace them all the time, then what I would do is take the IAC that you've defined and put it into self-service catalog, so that other people in the future can also use it for deployments as well. So that's a fairly good approach for how you would actually do your network and topology migration. Now, this is the more challenging one. When we talk about compute service migration, what we're dealing with is migrating things like application servers, applications, and server clusters to the cloud. It's not just about...
Can I interrupt?
Yeah, sure.
Apologies. Okay, so somebody has asked, what is the difference between static data and file and directory data? And I'm guessing now is a good time to raise it, because you're probably about to start talking about them.
Okay. Yes, it's a distinction between data which doesn't change a lot and data which does change a lot. So the sort of examples I was giving were things like video data. So video data you usually create and you basically move it to a repository store and you just leave it there. Now it becomes a distinction which is important to cloud services, because you will often be charged more for data that changes a lot. So if you've got data which doesn't change a lot, i.e. static data, then the costs for actually storing that data and using it are a lot cheaper than data which changes a lot. So hence that's why I made the distinction.
Okay, I would have thought file and directory data would have fallen into that category.
Have you ever heard of S3 storage?
Vaguely.
Yeah, okay. AWS has something called S3 storage. It's primarily set up for allowing you to sort of access videos, really, and data which isn't really what you call file data. It's a subtle distinction that may not be, obvious on the outside, but it does start to become a bit more obvious when you actually start to dig into the cloud services and how you actually make use of those services.
So I guess what you're saying is actually a deep understanding of the particular services that each cloud provider provides will probably lead you into splitting up and categorizing your data in different ways depending on where its destination is?
Yes.
Okay.
Yes.
Good.
And it's okay, it's a subtle distinction, but it does have implications on which type of services that you use, which is why I sort of split them up.
Yeah.
You know, file data usually goes to a file repository or a file store of some kind, and the cost of those, that's a different type of resource. So the cost of that resource is different from moving static data and the uses that you make of that static data. Now, I mentioned something called content distribution networks. You use content distribution networks for mainly being able to increase the speed of being able to access things like video data. So if you have large static data, then if you put them into, you'll have, okay, we're getting into a bit more deep details now, but if you're let's imagine you've got a website that basically you want to stream videos from, which is not an uncommon occurrence these days. Depending upon where you access that website from will depend on where you are in the world. Now, because you're paying for the amount of data that actually is getting transferred, what you obviously want to do is be able to try and move or have caches of that data that are closer to the actual people who are accessing that data. So if I'm in Asia, for example, it's going to cost more for me to go and stream data from the US or from Europe than it might be from, say, somewhere else in Asia. So it's basically ways of being able to categorize data based on the nature of that data, and then use the services that are more applicable to that data, to the nature of that data, than it might be for other types of data. I know it's a bit of a long-winded explanation, but I just, did you sort of get the distinction? And
yeah, no, it makes a lot of sense. Yeah,
okay.
Thank you.
It all comes down to how you use the data and the types of services that you want to use for managing that data. And every service in the cloud always has cost consequences. And there are some services that are cheaper than other services. So if you make use of some services that are more expensive, then you might be overpaying for what you actually need. So it's basically a way of being able to categorize the data in such a way that you use the cheaper services applicable to that type of data.
Sure.
Okay, so where did I get to? Okay, so it's not, when we talk about compute service migration, we're talking not just about moving infrastructure, but we're also talking about moving application logic and application architecture. And there are three main ways of being able to do this. There's the rehost, which is the lift and shift approach, which is let's just virtualize the existing on-premise host, upload it to the cloud, and we basically just create new instances based on that VM image in the cloud. Nice and simple to do. It gives you the advantage of being able to make use of some services in the cloud, but does have the challenge that it doesn't give you the full benefit. So nice and easy way of doing it, but you don't get full advantage of actually moving to the cloud. It's like the poor man's approach for doing setting up something in the cloud. Then there's replatform. Replatform can be used when you're migrating services to similar cloud native technologies. The most usual ones that you apply it to might be things like application services, application services, and databases. So basically, one use case might be if you've got a web server that's running on top of Tomcat Apache or IIS, what you can do is you can set up a Tomcat Apache in the cloud using a cloud native equivalent of Tomcat, and just basically take your binaries and dump them straight into that cloud managed service as is. You don't need to make any changes. You get the full benefit of actually using that cloud native services, because it does all the scaling for you, it does all the backup for you. And you don't need to make any changes to your actual application. So that's another, shall we say, easy way of being able to migrate some types of services over to the cloud. And the last one, and the more complicated one, but gives you the highest return, is where you actually refactor your application logic to best make use of cloud services. Now, this could be a whole sort of debate and discussion and presentation on its own, because it's a bit like science and art. You know, there are certain things that you do, but it's all really dependent on the type of application architecture that you have. But basically what you do is you're trying to look at decomposing your monolithic application logic into something that we can call either microservices or macro services. And then you do something called Dockerize it and deploy it to a container service like Kubernetes, which I'll cover in the next slide. And then you use things like native messaging and event management services to handle how those microservices talk to each other. Now, that might sound a bit like gobbledygook, but you know, if you're going to make best use of the cloud, and you really have a service that you really need to scale, then the refactor is probably the best way of being able to do that. And when I talk about scale, let's just give you a typical example. There's a messaging service called PubSub in GCP, which can handle millions of messages per second. So if you're basically looking at to scale your application to be able to, you know, handle anything the world can throw at it, then you're really going to have to look at how you can break down your monolithic application and refactor it to basically fit in with the cloud architecture, if you like. Because if you don't do that, then your application will effectively just be a cloud equivalent of your on-premise system, which will give you some advantages, but it won't allow you to take full advantage of what the cloud can give you. But again, it's all based on the use cases that you may have. So I'm just going to give you a very light introduction into these two topics because they are so critical to anything that you might look to discuss when you're thinking about refactoring. But I'm no way going to sort of give you a deep dive into these technologies because they are very, very sort of complicated. But I think it's worth actually just introducing you to the concepts. Now, there's a concept called containerization, which is mostly done by something called Docker. And containerization is the process of building a very light self-contained image that has all of the OS middleware and deployed binaries baked into it. So conceptually, it's almost a bit like VM in that you can create an image which has everything in it, but it's very different from VM in that it's a very, very light image. Now, when you create a VMware image, you know, it's not too unoften to have an image which is like many, many terabytes in size, or even petabytes, or can be a petabyte in size, you know, because you're virtualizing literally the entire operating system, the disks and everything. Docker doesn't work like that. It does it a completely different way. So the image that you end up with is very, very small. You may be 100 meg at most. And it's so critical to cloud because once you Dockerize something, or you create what they call a Docker image, then you can deploy that Docker image to lots and lots of different types of cloud native technology because it's totally portable. So it's effectively a self-contained image that you can deploy to, you know, lots of different cloud providers and lots of different technologies within those cloud providers because it's totally portable. So it's a key technology that many people use when they're actually starting to refactor their services in the cloud. The other one that I'll introduce you to is something called Kubernetes. Now, Kubernetes was what we call a container orchestrator. And a container orchestrator is effectively an all-in-one technology for managing the deployment, monitoring, scaling, security, load balancing, health, inter-process communication of any containers that get deployed to it. And if you start looking at cloud seriously, then these two will come and hit you in the face right at the start. So my advice would be get someone on your team or have a look at these two yourself, because anytime you start to look at the cloud, these two will be something that you'll have to get to grips on very, very quickly. And because they are so, shall we say, wide in the scope, they can be something that takes a bit of time to wrap your head around. Okay, so that's mostly dealt with all of the technology and most of the sort of cloud introduction, if you like, and you know, how do we do migration. Next, we're going to actually have a look at the business impacts. So I will pause briefly here to just ask if there are any questions before we jump into the sort of final main section, if you like. So Kylie, do we have any questions, or is everyone either totally mind-boggled?
Sorry, I was
lost,
on mute.
or
I was on mute. We do have one
right.
question, but I suspect you're going to say that it's you'll be touching on it in the business-oriented section. The question is, how does cloud look over time in terms of costs? Is it generally in line with inflation? What are the drivers for costs, which I think we've discussed a little bit already? And what inflation of costs should we build in over time?
It really depends on the sort of, again, I'm going to give you a nice waffy answer because it's very different. It's very specific on the types of services that you use. Generally, it's because all the services that you're using are metered services, you can arrange things so that you're only paying for what you really use. And there are little tricks that you can use for putting together those services. So, for example, if you're looking at storage services, you can do things like use services that you're only paying for sort of certain types of access during a month. So there's something called, now what is it? It's not hot, it's warm services, I think it is, or near services, where you're basically saying that I'm only going to access this data actually maybe a couple of times a month. So I'm only going to sort of pay for what I use. So you might get a cheaper deal than if you actually sort of say, this data is going to be available all the time, and I want it to be available all the time. And there's also types of plans that you can use for application logic as well. So you can do things like commit. There's three types of standard cost plans. One is sort of called committed use, where you basically pay in advance for what you use, and then you sort of have that cost fixed in. So if you overuse, then you don't actually get charged for that overuse, but you don't get charged for that overuse within reason. Or you have what we call hotspots, which is like where you architect your application to use instances that are only available certain points in time during the day. You might say, I've got batch type applications that I'm going to, that can sort of run on any available bit of compute resource that gets spare or gets made available. So it really, it's a bit of a challenging question, but basically it really depends on the deal that you can do with your cloud provider, the type of plan that you actually commit yourself to, and the type of services that you actually decide you want to use. There are various tricks that you can use to sort of pay less than you might do if you were actually wanting to go full cloud.
Can I jump in actually? Because I'm actually a member of the FinOps Foundation, and FinOps being financial operations is what it stands for. And their entire raison d'etre is to develop a framework and actually manage cloud costs. So they have training which explains sort of a lot of this stuff that you're talking about right now, Tim, and you can do the training and become certified. But actually, if you work in an end user organization, by which we mean you're actually at the pointy end of trying to manage cloud and manage cloud costs, then they're actually open and you can just ask to join and they'll let you in even without having done the training. I had to do the training because I don't work at the pointy end, I'm a consultant. So actually they are just such a fountain of resource, or a fount of resource, for all of these sorts of cloud financial management questions. So please do check them out for anybody who is cloud curious and wants to know a bit more about the costs, or indeed trying to manage cloud costs.
I'll also mention something else as well. Each of the cloud providers has what they call a calculator or an advisor. So basically what you can do is you can put in a general idea about what you're going to use, and they will advise you based on that cloud calculator about the best services that you can do and the best sort of plans that you can take out. There's also usually things called advisors, which will basically look at what you're using. So if you set yourself up in the cloud, you've used it for a bit, you can use these advisors to basically interrogate the use of the services, and they can give you advice on how to cut costs as well. So there's plenty of utilities to help you do that. But basically, yeah, you really pay, you're going to a metered service model. So, you're paying for what you use. So the best way to think about it is what am I using and how can I use something different that has a cheaper rate?
But also relate that back to the business benefits. The FinOps Foundation talk very much about the importance of calculating unit costs and unitizing your cloud costs so that you can draw as direct a line as possible between revenue, profit, and your actual costs. And again, if you go into and join the FinOps Foundation, you'll find lots of discussions about how to really closely relate costs to the people in the business who are using the services, so they can make the decisions about whether or not the services are worth it, whether or not they're getting the return on investment of those services. And then the business can also help make the hard decisions about, well, do we switch this service off? Do we switch different things off? How do we save money? Can we, are we willing to have a lower level of service because we recognize that, that's that much cheaper, and really this particular service isn't earning that much money? So really do check out the FinOps Foundation. And I guess in terms of the inflation element of the question, it's also something that they would be able to answer, because a lot of people in the FinOps Foundation have been managing cloud for a long time. So they'll have a sense of what inflationary pressures are in the cloud.
So I've just gone back to this slide that I was talking about, the actual methodology. One of the key things that you do during your discovery process is you build a business case. You're not moving to cloud for just the joy of moving to the cloud. There has to be some benefit there of doing it, and there might be there will be a financial business case. That may be one of the key points. There will be other ones as well, but you should do that research to actually make sure that it is actually worth moving to the cloud during this discovery phase. So as Kylie was saying, do that business due diligence, do that research, make sure that you actually have a business case for moving to the cloud. Don't just move into the cloud because it's nice and shiny and cool to do so.
And keep reassessing that business case as well.
Yeah.
So somebody else, actually, while we're on this slide, Tim.
Okay, hang on.
Somebody else has said, can you keep a backup of what is migrated to cloud so that if there's no internet, there's no interruption?
Yes, you can. Now, it will depend on the type of service that you have. Now, if you've heard of a term called DRaaS, or disaster recovery as a service, a lot of the cloud sort of services have that as an add-on. So you can basically sort of have your services backed up automatically and available automatically. So if something goes down, there's a new resource that comes up automatically to help you recover. But if your internet goes down altogether, then you are effectively screwed. There is no well, again, it depends on the service and what you set up. I mean, there are services that you can do which on a hybrid system that basically can work with the cloud if the cloud goes down. But if you're using different types of services like the data hosting services and the cloud goes down, and you've got all your data in the cloud, then yeah, you are effectively screwed at that point until the service comes back up. Again, it's part of that assessment that you need to do. So if you're going to go to a hybrid cloud approach, then you need to assess, what's going to be on premise and what's going to be in the cloud, how you're going to do your DRaaS, how you're going to manage your backups. That's sort of looking at the next level. So when you do your assessment, all of those have to be part of your technical assessment.
Great, thank you. Hugo has just made a comment, which I'll just read out loud so that people who are listening on catch up or watching on catch up hear it as well. So Hugo says, a good book, if anyone is interested, is Digital Evolution. He's actually put in a YouTube link, which is interesting.
Cool.
And then somebody else says, we have an application which is currently delivered on premise to clients, but we are considering a cloud version because everyone expects applications to be in the cloud nowadays, ! We are now questioning whether that is a good enough reason. Do you have any comments?
I would say if that was the only reason, probably not. You could certainly research it, maybe there might be some cost advantages of doing it. But if that's the only reason because it's a nice shiny thing, then I would say probably not. Again, you have to, it's not going to be one or the other. It has to be a balance between, what is the client expect? Sorry, what is the customer expecting? If the customer has an expectation that you should be in the cloud because of or most of your competitors are in the cloud, then maybe that's a good enough reason. But I wouldn't say just do it because it's nice and shiny. There has to be a good reason for doing it.
Yeah. Right.
What that reason is, what that reason is might be a package of things. It's not just one or the other. It might just be a package. It might be customer expectation plus costing plus managed services, or it might just be, you have to look at it within the bigger context.
Yeah. Okay. So it's nearly 20 to 8. So shall we sort of scoot through the business oriented section? Because I think people will be really interested in that as well. And if you do have any more questions or comments, please keep them coming. It's great to have a good discussion like this.
Right, so business impacts. I'm going to, due to the time, I will try and sort of, shall we go through this slightly quicker than what I normally do? So like any organizational change, there will be potential impacts that need to be considered, both positive and negative. Now, this would be a good place to start, but it's not the sort of be all and end all of what those impacts would be. On the positive side, you've basically got potentially cheaper costs. Now, because you're using a metered service, you're only going to pay for what you use. And the cloud has utilities that allow you to sort of look at what you're using and choose potentially cheaper options. So, you get that visibility there. And hopefully, because of that visibility is there, you can sort of decide how you can make your general costs cheaper. You're using managed services, so things like patching, upgrades, availability of those services are managed for you. You can basically be aware that if something does go down, then that service will probably automatically come back up because those services are managed, and the availability of those services being available. Sorry, those services are managed for you, and the availability of those services being available is also managed for you. So if something goes down, it will probably come back up very, very quickly because a new resource will be made available by the cloud so that you can actually pick up that slack. Elasticity. So if you have services that basically you have large peaks and troughs in demand, and effectively you're having to build for the high-end case rather than the low-end case, because your services will scale automatically with demand. You're not having to build up that high capacity anymore. You can just basically deploy it as such. And if you suddenly get that peak in demand, the service will scale up. And then if it goes a low demand again, it will scale down, and you don't need to pay for having that high capacity available all the time, even when it's not being used. On the maintainability and what we call that service reliability engineering, there are lots of supporting technologies that can help sort of diagnose what's wrong with your systems. Those come out of the box. So that supporting technology like monitoring, tracing, DRaaS, which is disaster recovery as a service, is provided for you, and you can integrate them basically a lot easier than having to build in third-party solutions. You have some level of being able to choose control, so you can decide whether you're going to go the IaaS service route, which is where you have virtually full control over the types of infrastructure that you're using, or if you're going to go the PaaS route, which is the platform as a service, where you basically say that, I'm going to hand over all control of that type of service, well, most of the control of that type of service over to the cloud provider and go with a low code type approach, if you ever heard that term. Then we've got empowerment. So what you'll find is when teams mostly go into the cloud, those teams like to have ownership of those services all the way into production and ownership of those services on production. So the product team doesn't just do the development of the service, they also own the service in production and sort of maintain that service in production. And that's a common approach that most people will use when they have some maturity in the cloud. On the negative side, of course, there's going to have to be some reskilling. So because you're introducing cloud type services into the mix, then you have to make sure that your ops teams, your runtime teams, and your dev functions are reskilled in being able to understand the cloud. Because you're moving from an on-premise system to a virtual system, there will obviously be some loss of control over that environment, which may be a challenge for some types of people or some types of functions. Security, compliance, you may need to consider how you're going to do that. There's processes, obviously, because you're moving to the cloud, that there may be some business processes and structures that may need to change to reflect or better adapt to support that cloud. DevOps, Ops, and SRE are three, usual good examples of things that you have to consider how to change. You may need to refactor your application. So if one of the reasons you're moving into cloud is because you want to make the best use of those that throughput, that scalability, then to do that, you will have to actually refactor your application to do that. Then there's migrating your existing solutions. So you may have on your on-premise system, you may have existing solutions for monitoring and recovering. You'll have to replace those. That will increase the cost. And then, of course, there's the downtime for the actual migration itself. So that may be an issue. So how do we mitigate these? Well, if we look at the business impacts or the business side of it, my advice would be do your migration incrementally. You don't need to migrate everything over at once. In fact, you'd probably be a bit foolish to migrate everything over at once. So scope what you need to migrate, go through that backlog that you created for your migration, and just migrate what you need in like milestones or phases. When you do your migration, keep in mind that you've got a brownfield versus a greenfield site. If you've got a greenfield project, then design with the cloud in mind. If you have a brownfield project that you're trying to migrate into the cloud, then use these rehost, replatform, and hybrid approaches to start with. Don't try to refactor everything into the cloud at the beginning, because that's just asking yourself for a world of pain. For staff and teams, you will obviously need to retrain your existing staff in cloud technology or augment them with new hires. If you have an ops function, then you need to decide, are you going to keep the ops structures the same, i.e. a centralized structure, or are you going to move those ops functions into your project teams? And the approach that most people use when they have a mature sort of setup in the cloud is they move their ops functions into the project team. And you also need to consider the budgeting implications and the funding models. So are you going to stay with a centrally funded ops function, or are you going to move to a distributed project funding? So are you going to basically say, each project is now responsible for their own cloud funding. So basically we will move the funding away from a central model to a more project specific funding model. So review which approach works best for you. When you come to the technology, then start off with the data services first, because those are the easiest ones to do. Then do the compute, and then do the networking. But beware of things like source of truth issues. If you've ever heard of source of truth issues, basically, if you have many data sources and you're migrating them over, then you need to make sure you have one data source as the master, and the rest of them are the servants until you actually have done the full migration. And then you basically change that one data source to be the truth. If you are doing incremental migration, then always make sure that you implement security IAM policies and budget controls and SRE practices in line with the services that you migrate over. So even if you've only done partial migration, then you still need to set up security for those services that you've partially migrated over. It's not something that you do at the end, it's something that you do continuously. And also my key advice would be have a cohesive end state in mind even if you are only migrating parts over to it. There's nothing worse than basically doing incremental migration and doing it in an evolutionary way, and then sort of coming to the end of the migration and say, oh my God, how am I going to stitch all these pieces together? Madness lies that way. So always keeping a cohesive end state in mind. Use hybrid and hybrid and re-platform solutions where you can, because that makes migration a lot easier. And I will not do the last bit because of the time. So migration summary. Why is it not scary? Well, the key things to keep in mind when looking at any migration approach is the following. Migrations can be done incrementally. You don't need to do them all at once. So put together a backlog of priorities for your migration and then go through that backlog. Even if you migrate bits and pieces over, they will still give you value. Many services can be transferred as is. As I said, lots of the on-premise services that you can do them using the re-platform method. So lots of those services can basically just be effectively lift and shifted from one technology to the same technology in the cloud. Only migrate what makes sense to. So you don't have to migrate over everything. If you have certain things that it makes sense to migrate over, then migrate them over. If there are things that you don't need to migrate over, or you're not going to get a good value of return on investment to doing that migration, leave them on the on-premise. Hybrid cloud approaches allow you to do the best of both worlds. So, if there are services that you want to migrate over to the cloud because you have a very good use case for them, but the sort of business case for migrating other services isn't really good, then what you can do is you can use a hybrid approach so that you can leave the ones that don't make sense to migrate over to the cloud on premise, and you can get them to work with the services that are in the cloud quite happily. Even if you do move services over to the cloud, you will get some benefit. If you really want to get the most benefit out of it, and you have to do refactoring, then you can do that refactoring of those services in a gradual way. You can sort of say, well, it makes sense to refactor this part first, but we can do these afterwards. Then do it in a gradual way. You don't need to do it all at once either. And last point is, migration tools do exist to help you with this migration process. It's not rocket science. It has been done many, many times before. So some tools exist that can help you with that migration process. If you're looking to experiment with migration, then I would highly advise you to start off with Azure, because the migration pieces in Azure are a lot more superior than that with AWS or GCP. In fact, GCP is a BBB nightmare to do a migration for. So if you want to experiment or start off in a sort of simple approach, use Azure. It's very nice, the migration pieces that they have there. And maybe one mental map or one mental maturity model for keeping in mind to do your migration is this one, which I have here. Start off by scoping the migration, then migrate the as-is services, consolidate the services that you've migrated to make sure that they're all working in the cloud and working well, then start to do your refactoring. And then finally, once you've if you're developing new services or you've done your refactoring, that's the point in time that you start architecting for the cloud specifically. So in summary, cloud services are managed IaaS or PaaS services that are hosted in the cloud. Cloud migration is simply the movement of data or infrastructure or applications to those cloud management services. Any cloud migration strategy that you do must include both business and technical objectives. You don't just do it because it sounds like a good idea at the time. There has to be a good use case for doing it, both from a technical and a business perspective. Doing migrations incrementally based on your business priorities is probably the best way of minimizing the impact of doing the migration. Using rehost, replatform, and hybrid strategies minimizes the actual physical migration work involved. And refactoring your migrated services is needed to make best use of the cloud but it isn't essential. Though, I mean, you can move services into the cloud and get benefits without refactoring them. But if you want to make the best use of the cloud, then you have to refactor. So finally, why is migrating to the cloud not scary? Well, if you plan it right, you can do it in small bits at a time and still get great benefits. So we have a couple of minutes spare. So sorry for that extended rate. I just wanted to get us in time enough to getting some questions.
So at the moment, there's just one more question. Are there cloud applications which are hosted externally, but not using AWS, etc., i.e. by a private provider? Or does everyone use the big three? And I guess this is getting into the complicated world of
I mean, there are
private cloud and
yes, there are other providers than the main three. Ionis is one, for example. If you're okay, so the use case for using one of for not using one of the main providers is if you have some specific requirement, and for example, making sure that data is not hosted in the US might be one of those requirements. And there are cloud providers like Ionos, which is IONOS, which are only hosted in the UK, or sorry, only hosted in Europe. So if you have use cases where you want to sort of minimize the impact of hosting data and you don't want to sort of have it ex-territory and be applicable to those ex-territory like rules, then that might be one use case. Other use cases might be where you want specialist services like AI services. So it really depends on the type of service. But, you know, to be honest, most of the three providers, they provide quite a good range of services. So you'd have to have a pretty oddball use case not to want to use them.
Great. So before we go, I hope that made sense to everybody. Before we go, does anybody else have any other quick questions?
I will, if there aren't any, I'll just add something. If one good use case for having a private cloud is if you have a big enough infrastructure that you've already set up, and you already have some sort of cloud service already running within that infrastructure, then that's a good reason not to go to a public cloud provider. And IKEA, for example, was one case where that was so.
Right. So I think just a comment, Mario says, I arrived late and attended half the lecture, but still learned a lot. Many thanks. It's been an excellent talk. So I think everyone would agree with that. Whenever we have you speak, Tim, there is just an avalanche of information that we,
I know,
in a good way.
I appreciate that. I appreciate that. But as I say, that the slide decks are available, and hopefully you can use those as like a research resource to start you off on your journey, and then you can say, "Oh, Tim mentioned that, so let's go and have a look at something on the internet."
Yeah, definitely. Yeah, and PK Fraser says, excellent presentation. Many thanks. So yes, to echo those people, thank you very much, Tim. It's been a really great talk. Daniel Alabede, so Daniel, I guess, thank you for the update and insights. It was well worth attending. Jia says, thank you so much, Tim, for this very structured and content-rich webinar. Is there a way that we get notified of your next webinar?
I think, well, I have volunteered a couple of other topics to Kylie to sort of discuss in the future. Basically, what I would suggest is suggest topics, and if they're relevant, I'll happily talk about them.
Yeah. Yeah, and I think we've sorry,
Kylie, just to butt in, I had one question in the last couple of minutes for Tim, which was, and you touched on it just now, which was a lot of these cloud service providers are in Europe. UK is now outside Europe. It has got data protection equivalents, but do you have you come across difficulties with standard contractual clauses or other elements where it's difficult to legally transfer the data backwards and forwards?
Yes, it's not, I won't say so. Most of the experience I've had, or most of the challenges I've had with this one were specifically to do with implementing cloud in Russia and China, where they have very, very strict rules about being able to move data out of those countries. In the case of not moving data to the US, which is the other one that specifically comes to mind, there is ways of being able to do that in the main three providers, but you sort of have to build that into your contract, because sometimes they will do it as part of their internal routines. You have to remember that each of the three providers do have global services, and each of the services are scaled to a global level. So they will automatically back up data between, maybe Europe and the US, simply because they want to make it available in case there's a data outage or a power outage or something. So if you're going to go with one of the three main providers, then you have to be sort of specific in the contract that you do with them, to make sure that that doesn't happen. But as I said, there are other providers that are limited in the scope that they have, like IONUS was one very good example, and they will not move data to the US, or they will not move data to outside of Europe. So you have to basically do your research and try and put together a contract that best suits your requirements, if you like.
Great, thanks very much for that.
Okay,
that's it.
I think we are done, and we've just come under 8 o'clock as well. Even better.
Yes, fantastic. Thank you so much, and speak to you soon. And thanks everybody for attending. Bye.
Thanks very much, my friends. Cheers.